Hi, my name is Cameron Atkins, and I am doing a research project as a part of SRP 321 titled Exploring Advantages and Implementations of Modular Game Content in Online Open World Games, and this was supervised by Dr. Justin Carter. This is to research and conceptualize implementations and advantages of using modular game content and features in response to issues identified with large-scale live service online open world games. So first of all, we just have some definitions. First of all, game preservation. Efforts to preserve games to be playable for many generations and preservation of media is a legal and moral obligation. Secondly, we have games as a service, or GaaS, video games that are provided through online service. They can either be games that require an online connection or are completely streamable via video. And downloadable content refers to additional content that can be added to a game after the initial release and are often optional with a separate payment. So the problem we have here has to do with preserving online game experiences. So this research aims to address the gaps identified in game production methodology that causes live service games to become too complex and contain too much content in order to be properly maintained and developed. These inefficiencies can lead to removal of older content to shrink a game's size to a manageable level. A prime example of a game that has these inefficiencies is Destiny 2. Old production methods lead to the creation of the Destiny Content Vault, a system in which Bungie cycles out and removes older content to accommodate new downloadable content. As Destiny 2 is a GaaS game, which is a game as a service, older versions of the game cannot be played, and only footage remains of the vaulted content. This can be particularly problematic as Destiny is a progressive narrative-driven experience and new players miss out on key moments in its story progression. The problem can also affect other expanding games and season-focused games especially, like Call of Duty Warzone and Outriders. This is some of the content that was vaulted by Bungie, which included the Red War, Curse of Osiris, Warmind, and recently Forsaken campaigns. All of these featured important narrative content that could be no longer accessed by players. Essentially now new players start with the fourth expansion, Shadowkeep, which is much later on in the Destiny 2 narrative. These expansions contain destinations, missions, and activities no longer playable today. Many AAA games now are financially supported by extra revenue received from post-release downloadable content. Some of these games feature subscriptions or season pass models that constantly provide new content to games for years. Many games that feature a lot of expandable content become more complex. These increasing complexities make development more complicated. On a technical level, these can be due to the static build software environment. This can be possibly alleviated by employing more modular dynamic production values. This research aims to deconstruct, plan, and implement experimental features and identify uses of this research to help bridge the identified knowledge gap. I have identified a knowledge gap and used industry cases and official documentation. The example project will show how these features will work and how it will address this knowledge gap. This research tests the hypothesis of which involves combining content modularization and delivery to preserve features of online games. This exploratory design study tests unexplored methods in the game production field. The criteria will involve a successful implementation of both experimental features functioning as described. So modularization is a technique that separates and classifies objects in a collection to allow for said object to be repeatable, reusable, and less dependent on other objects. This technique is very common in game design and benefits production complexity, ease of development, and overall game performance. It's traditionally used for both graphical assets and code. So Modular Game Features is an experimental feature available for Unreal Engine 5. It allows for seamless content injection in game and in editor. Game content can be made individual components called game feature plugins. These game feature plugins can contain a vast variety of game content, including visual assets, code, and game elements such as gameplay types. This is an example of how a game would be constructed with game features in mind. Essentially, most games are created like the components in the teal area, which are all in the core game. Game features allow for content that can exist outside the core game with various dependencies and hierarchies. Another feature of Unreal Engine is to allow for content to be stored into chunks of game file data called packs. Chunks are classified into chunk IDs. These IDs are the identifier that tells the engine what content to load together. Chunks can be arranged into collections and can have dependent and codependent chunks. This feature allows for downloading and installation of the chunk files. This allows for the game to change its available content during runtime. A game can essentially be patched without stopping the game and creating and downloading a new build. So just to make clear the two experimental features, we have modular game features, which is the modularization of game content in terms of development in editor, and the chunk downloader, packaging of this content in terms of distribution to the player. Creating a modular feature plugin that makes use of the chunk downloader is possible, but not yet being exampled by either Epic Games or in academic research. So this hypothetical game implements game features for optional seasonal events, such as this Halloween event. It contains unique Halloween themed items, a broomstick flying minigame, and a spooky mission. The spooky mission is a variant of the core pirate level and uses this content. So in this variant of that same game, the once core pirate content is now an optional game feature, essentially making legacy game content optional. Some content will always be required, such as the core FPS gameplay and its associated content. So using the modular game features plugin, the content needs to be organized into two separate areas. Content in the main content folder will be included in the main game. The modular game feature plugins will go into its own folder in the plugins folder. As you can see here, we've got content in green here for the main game, that's core experiences, the main level. Then we have all these blue folders here that are the plugins, right? So we have first one here is for actually our character that we're going to download using the chunk downloader. And then we have two others here called Neo City and Village, which are content packs. So if we open up our content browser, we can see that each of these content packs essentially has their own unique content inside. So our green folders here has blueprints, maps, materials, textures, etc. And we have very much the same thing in each one of these plugins. So a core component of the game feature is a data asset. This controls the initial and current states of the feature and tells the game feature what will be included in that game feature. In this example, we have mostly actors, but we can include other things such as levels and other features like gameplay types and things of that nature. So any scene that includes a game feature requires a receiver. This is stacked to an actor in the scene and is called the start and end of the runtime. Game features can have their states changed during runtime. Currently, this is handled through console commands, but we can essentially load them into a blueprint like this. So the example project uses an actor class that spawns when the game feature is activated. Game features consider both begin play and end play as the time they are activated and deactivated. At the end play, this actor also needs to be destroyed, as already activated features will stay in the game unless they're removed. Spawn location also needs to be considered. To organize this better, use of reference points such as an empty socket actor can be used in place of raw location. So this is a example of what the project actually looks like when viewing in the editor. As you can see, it doesn't show any of the content at all. All we can see is the socket actors. The content will be in a loaded state, so it's relevant to the engine and only shows when the game is actually played when those game features are set to activate. There's a possibility of also using dummy actors like low poly meshes to put in there to convey those replacements as well. And then they can be hidden during runtime. So here we have an example of what the game looks like when it's running. In this example, we have a plugin that is displaying during runtime called NeoCity. And that's because we've set this as the initial state as being active. And that means that when we run the game, this will spawn in immediately because its begin play has been triggered. The other two are the character, and we've also got a mini village that actually doesn't spawn yet because those are marked as registered. So they're ready to go, but they haven't been spawned in yet. So next we need to get on to looking at chunking as well. So chunks also feature a data asset, which is included in that same plugins folder. Here we can specify a chunk ID with a priority in downloading and other rules related to asset management. So this one, chunk 1002, relates to an example downloadable character model. And this character model is actually hosted on an external web address. So it is not actually in the project at all at the moment. It will only exist in our project when we install it. So if we have a look at this one for chunk 1002, which is our character, we can see that basically what this does is we click a button and it downloads a file called a pack. It mounts that pack into a temporary location, and then we do the first integration with our game feature, which is to activate the game feature. Now, this is important in this regard because we're downloading a game feature that will still need to be activated and deactivated. So we could also use this to download the content and have it not activate until we're ready for it to activate. So here we're just showing how it looks like in the content directory. We have one pack here for 1002 that is currently in a temporary download location. Right now, what would happen is that when we run the game again, there's a flush of this cache, so it will delete. And then if you want to have the character again, it will have to download that from the content server again. So here I have a demonstration of the project in-game, and I'll play that now and we can have a look. So first we can see that there's actually nothing in the level at all. It's completely blank. The tiles, the sun, the sky is all considered core game. So that is actually in the program as you receive it. And if we play that, I should be able to click on install NeoCity. So what that's done is called that content pack, that game feature plugin, and activated it in game. So in this example, I do not have these hosted online because they would be very big and we would have to wait for them to download. So these are not using the chunk downloader. So these are in-game right now and can turn on and off without internet. But if we have a look at the rest of this, so if we go closer, we can install our game character. Now you can see this actually invokes a download meter. So it's 11 megabytes that is downloading right now, and it has successfully downloaded it. So we've also installed another one there, which is another content pack that is separate as well. And it's the same deal as the NeoCity. It is not part of an online service, so that just installs and activates straight away. And then to remove them all, we just click uninstall all, and basically they're all removed from the game. That game is completely unaware of their existence and not dependent on them anymore. So how can we actually use what we just saw there to benefit game industry development? So we can make plugins for entire maps. Making plugins for the entire levels is possible. All the content relating to the level will either need to be contained in the plugin or have another plugin with declared dependencies. We can also use more advanced data registries. If there are a lot of plugins in the game that are constantly turned on and off, data registries could be used to properly manage dependencies and hierarchies. We can wrap up the optional content. This will include content like language packs and other player-focused accessibility content. We can use it to host out-of-date content, so that legacy content that was mentioned before. This can be used to make previous content available, like those story missions and campaigns that can be downloaded on demand later and still be independent from that main game. And of course, I think the biggest part about this is that it makes development easier. Just like modularizing other developmental pipelines, this can allow for a lower level of complexity in game structure and possibly speed up game development time. So there are some limitations identified here. As these features are considered experimental, some of the components and their functionality are either limited or not yet available. Some of these identified limitations are game features are not fully featured in code yet, require console commands to work. As such, game builds are limited to developmental builds only. Some of the features only work within the editor and do not work within the built game. Clearing the content cache is only method of deleting content right now and currently cannot be selective. Other methods may be possible, such as manually targeting files on disk, but this is outside the scope of the research, and also you have to also edit that manifest file, which is a little bit more tricky. Deleting the content cache only functions when the game is run, not later during runtime. So in conclusion, using modular game features appears to be an effective tool to separate game content on a developmental level. Chunked game features are able to be downloaded and loaded from external sources without the need for a rebuild or even restarting a game. Migrating older content into optional content packs is completely possible. And in regards to online games, don't require all online players to have the same content packs. There are, however, still issues that these features do not help alleviate, such as developers no longer hosting a game. This is where traditional preservation methods are still key. And more research is needed into the uses and functionality of these features and how they can help aid developmental processes in the games industry.